Thank you very much. I'm going to skip the intro because that was an excellent introduction. What is it that we're going to talk about today? I decided for this year to, at Spring I to do a boot loot presentation inspired by loot boxes that you may be familiar with if you're into gaming, or like me, if you have kids that are into gaming. The idea with a loot box is you buy it, you don't know exactly what's going to be in it, but most of it should be good. And that's exactly what I intend with this presentation. So I'm going to cover various topics related to using Spring Boot effectively and efficiently. And I'm sure there will be something in there for all of you. The stuff that I'm going to cover is actually based on production experience, which means I'm not just going to show you things I made up. I'm actually going to show you things I made up and then put into production successfully, so it should be working for you as well. The first thing that we're going to cover is the default error page, or the default error rendering that Spring Boot provides for web applications that you may or may not be familiar with. But the idea is that if you don't specify anything yourself, and there is an uncaught exception happening in a Spring web application, then if it's a browser client, you're going to get a default error page called the white label error page, which will just show some details about the error by default without a stack trace. If you're going to use another client, programmatic client, that will be a JSON rendered message showing you the actual error, a message, and some other information. We're going to have a quick look at that to see what the results of that errors are when you are going to use validation in your objects. So I'm going to switch to IntelliJ here, just so you know. All of the code that I will be demoing is in the Git repo. I'll give you the URL at the end, so you don't have to take pictures or notes unless you really like to. What you see here is this big enough? Yeah, it should work. We have a purchase request here because we're going to buy a loot box. And in this case, we need to provide two fields. We need to provide the actual key or the EAN of the product that we're going to purchase. And we're going to say how much money are we actually willing to spend on this thing. Now, ideally, all of these game vendors would like you to spend as much money as possible, but at least in the Netherlands, they are getting some regulations into place on this thing because we're dealing with kids. And actually, some of the loot is actual gambling because you can sell the results. So in this case, we're limited to 25 euros that we can actually spend on this. With this class, what we're going to do is we're going to have a super simple Spring Boot application over here that simply consists of a single REST controller, which takes an incoming post request with some JSON, unmarshals it into this loot box purchase request, and then simply returns a string that says, hey, this worked. The important thing here is the @valid annotation that you see on the loot box purchase request. That means that before actually calling your controller method, Spring will first perform the actual bean validation checks in place on this object. And going back to the purchase request, again, both of these fields are required, they're not null. We have a range for the money, and we have a regular expression pattern saying that the EAN should consist of 8 digits. So with that, let's start the application. And then I'll show you what happens if we pass in, first of all, a correct request, just to prove that it actually works, and then make some errors in there. So application is starting up. Or actually, I have something running on 8080 already. Let me kill that first and then start it up again. There we go. And while that's starting up, I'm going to go to the command line here because I'm going to use httpy, which is like a human-friendly curl, to make some requests here. I'm going to make a post to localhost 8080, and I need to provide two things. I need to provide a product EAN, which is 8 digits, and I need to provide it was an amount in euros, but I forgot the field name. Euros to spend is that. So euros to spend. Let's spend 10 euros. And we should be getting back a response now saying this worked. Request was valid. That's exactly what we're after, so this worked. Now I want to show you what happens if I introduce some errors. So let's say I say, well, actually, I'm just a poor developer. I have no money to spend. I'm going to get an error. And obviously, the idea is that we need a positive amount of money. But if you look at what we're seeing on the screen here, is that we're getting a whole slew of data thrown at us. We're seeing some arguments here, which has a nested arguments field. Not very obvious what that is. Then inside of the outer arguments, we have code and we have codes. But then there is another field called codes, which is actually a combination of different properties that Spring will try to resolve into an error message if it would actually do some resolving here, which it doesn't. So you get this whole big thing where a client now needs to make sense out of this to say, oh, apparently the amount of money that I passed in was wrong. You get similar errors when you leave a field out. So in this case, again, you see that I have this whole bunch of fields and some error message that says must not be null. And then I have to actually look really closely to see that it was the euros to spend in this case that shouldn't have been null. And obviously, we're getting something similar if I create a wrong product EN here. Now I actually have 2 errors. You can see that there is an error count of 2. But it doesn't even fit on the screen, so I have to scroll back up to see that apparently my product EN must match a certain regular expression, which it doesn't. So this is what you get out of the box. And what's happening here is that when you get this validation error, that is causing something in Spring which is called a field error. And if you would look at the actual field error class, you will see it extends a class called a default message source resolvable. Now what that means is there is stuff in there that could be resolved by using a message source into an actual human-readable message. But what happens is that instead of that resolvement actually happening, these objects, these field errors, are simply marshaled out as is. So a lot of the fields that you saw there with all of the arguments and the errors and the codes, that's actually coming out of the default message source resolvable and some of the subtypes there. And I don't know about you, but this makes my eyes bleed if I see this. We try to create, in the project that I'm currently on, we try to create actual JSON-based APIs for remote clients, right? Not just for a web browser interpreting this from a Reactor or an Angular app. And this is a terrible user experience, basically, to provide to your clients. So this is something I wanted to fix when I saw this. So wouldn't it be nice if these field errors are, in fact, instances of something that says, I can be resolved by a message source, if it was actually resolved into a nice error message. And the good news is it's actually quite easy to do that because with Spring Boot, you can override the default implementation of their error attributes, which is called the default error attributes, and provide your own implementation simply by registering a bean. So that's exactly what I want to show you first. So here in my little loot package, I have a implementation which is called the resolved error attributes, which extends the boot-provided default error attributes. It isn't used yet because I haven't had component annotation here, but it's commented out, so I'm going to make that active now. And that will automatically ensure that Spring Boot will just pick up this class while doing its component scanning and turns it into a bean. What is it that we're doing here? We're injecting a message source, and Spring Boot in a web app actually provides a default message source, so I can just rely on that one. And then we override this method called getErrorAttributes by first calling the original method that we're overriding, then extracting a parameter called errors, which will return a list of object error, as you can see over here. And then what we do is we say, if there are any errors in here, what we're going to do is we're just going to loop over them. And for each one, we're going to do the actual resolving against the message source. So that's what you see here. We do a message source get message. In this case, I'm just going to use a US locale because I like English error messages in an API-based application, and I don't care about the actual language that the client may request for. And now we're doing one extra thing, because these errors could be regular object errors. For example, if you have a validation that spans the entire object, or they could be specific to a field. And if they're specific to a field, then I don't just want to show a message that says something like must not be null. Right? It doesn't provide you with context, so we need some additional context there. So in that case, we can downcast and we can say we want to get the name of the field, we want to get that error message, and we also want to have the actual value that people provided, so we can say this is the value that didn't match our expectations. Otherwise, we're just going to use the resolved message as is, and then we simply override that map with errors with our resolved error messages. And that's all there is to it. So with this in place, what we can now do is we can restart the application. Let's see over here. And now go back to our console here and make a new request. Remember, there were two errors in this request, right? I have an amount of money, which is 0, which it shouldn't be, and I have an extra number in my product EAN. And what I'm seeing now is that, let's zoom in a bit, is that I'm just going to get an errors array here with 2 human-readable errors saying the product EAN must match these 8 digits, and the euro suspend must be greater than 0, but the actual value provided was 0. So that's really all it takes to get a bit more sane defaults, basically, for rendering these error messages. And what I like about this approach is it prevents you from having to do custom error handling everywhere. And you can actually go with most of the stuff that Spring Boot provides for you, but take away some of the cruft that you get when simply marshalling out these field errors as is. So that's the first demo that I wanted to show you. And with that, we're going to have a look at another feature. It was actually a bit tricky just before lunch. There was a really good presentation here from Brian and the Spring Boot team about building web applications, and they actually showed off some of this support. But I'm going to show you a bit extra, so even if you were there, don't worry, you will learn something new. Spring Boot has a feature which allows you to bind configuration properties, basically just configuration coming out of some property source in the environment, to an instance of a Java bean. And then you can just inject that bean into your code, and you can read the actual configuration just by calling some getter methods. This is nice to use, especially if you have a lot of related configuration. You can just group them up as a set of properties belonging to a single class, and then have some common naming prefix in your properties to make sure that everything that starts with that gets bound to that class. That's actually a whole bunch of words to explain this, but it's actually much easier to just show you. So let's look at an example for this. We have, let's close all of this first. We have another project here, which provides a class called loot properties. You can see the theme here. In this case, we say we want to have a configuration properties class, and all of the properties that we use to configure this thing will be prefixed with loot. And then we have two properties. We have an allow transfer boolean, which tells me that if I buy some loot, am I allowed to transfer it to some other player in the game for money? Like, this is the thing that's actually illegal now in the Netherlands for underage people, because it's gambling. And we have an enum that specifies the game for which we want to buy some loot. And I've actually inlined that, so we have Overwatch, Fortnite, and FIFA here, because according to Wikipedia, those are games you can buy loot for. I'm not personally a gamer. Now, with this thing in place, what we can do is we have a little Spring Boot application class here, and first thing you may notice here is that we have an enable configuration properties annotation. There's actually two ways to enable support for a configuration properties annotated class. Either you simply turn that class into a Spring Bean by annotating it with that component, for example, making it eligible for component scanning, or you explicitly mention it as saying this is a configuration properties class that I would like to use and be instantiated using the @enable configuration properties. After that, an instance of that properties object is simply auto-wired into the class here, into the code, and then when it's injected, we're going to print out the game and the transfer that have been configured. So I haven't configured anything yet. Let me double check that I didn't. No, I haven't configured anything yet. So first off, what I'm going to do is I'm going to just start the application here. And what we should be seeing is that no configuration was actually provided. So both of these properties should just be null. So I'm starting up my application, and indeed we can see here that we do get an instance of the loot properties, but the game and the transfer allowed are both null. So that's what we expect. What we can do now is any way that Spring Boot provides us with, we can define some configuration properties for this. So an obvious way is through the application properties here, which is currently empty. So what I could do is I can say prefix with loot, because that's the prefix that we configured. And then say, what do we have? We have game. So let's say I want to buy for FIFA. And the other one was allow transfer. And we're going to set that to true. And then we're going to see if this works as expected. So restart the application. And there we see now that our string, which we actually specified in lowercase FIFA, is actually matched onto the right enum value, so that binding happens automatically. And indeed, our Boolean has been configured as well, and now we've set that to true. So this is basically what was also shown in the previous presentation. So what this shows you is this is a nice, easy way to group a number of related configuration properties. And it's easy to access these. You don't need to use a lot of add value annotations. You can just inject this Java object. So it's nice, but it's not that different from actually just using add value. We can also easily use things like default values with add value, as well as with configuration properties. So you may wonder, like, what do I really gain in doing this? And there's actually two important features that I quickly want to show you. First of all, you can get IDE support for this. And you're probably familiar with that already if you're using Spring Boot, because you get code assist in your Java IDE if you're editing things like application properties. But you can get that for your own things as well. And the other thing I quickly want to show you is support for bean validation, similar to the bean validation that we had in Spring MVC. So let's have a quick look at that. First of all, we're going to make sure that if I am in here, I want to be able to simply say something like this, do control space, and then get some suggestions. Currently, I'm not getting anything, but I can tell Spring to at compile time, do some processing for me, and based on my configuration properties annotated classes, generate a file that will be understood by all major Java IDEs like IntelliJ and Eclipse. So for that, the only thing you need to do basically is to enable support for this configuration processor. I've also configured my IntelliJ to actually have support for annotation processing tools. So this should be enough, actually. If you don't enable that explicitly, you should actually do a Maven build now in the command line to have this affected. The result of this is that, actually, it looks like it didn't do, so I need to trigger a build. There we go. The result of this will be that there will be a new file generated for me that tells the IDE exactly what new types are there. Let's see if it works, because I don't see it yet. Maybe I do need to have a command line. Ah, there we go. No. So what you see here is now when I do control space, I actually get a loot.allow transfer, which is a Boolean and a game. Also note that the allow transfer actually is using a dash here. This is called kebab casing. I'll get back to that. So this is nice, right? I can do this, and now because the IDE understands it's a Boolean, I get code assist on those values as well. Same thing is true for the game. So I could configure that, and I can choose that, right? I just need to press enter all the time until my application works. That's the ideal workflow for every developer. On the other hand, it doesn't actually tell me exactly what these values do. And ideally, as a developer, I would like to have an idea of what do these things actually mean. So what I can do here is I can go into my configuration object, and I can do some Javadoc. And I'm going to do that directly on a field. That's actually what you're supposed to be doing here. So I can say defines if transfer is allowed. And there's a typo there, but that's OK. And then the other thing I can do is say what game are we buying loot for? Like that. So what will happen now is this information will be taken into account by this annotation processor tool. It will be put in the same metadata file read by the IDE. And now if I go back here, I can actually see that, for example, if I start to configure this, let's have a... There we go, let's do it like that. I can actually see the documentation here that says, what game are we buying loot for? Right? So this is perfect, because this means that I can actually start to discover the available configuration as a developer on the application that I'm working on with my team. See what values are there. It will also show you default values if you have configured anything like that. And you can provide some built-in documentation as well. The other thing we can do now is we can actually go back into this thing, and we can, the loot properties. We can annotate it with @validated. As soon as we do that, Spring Boot will automatically apply some bean validation to instances of this thing after our properties have been bound. So what that means is that we could say, well, the allow transfer here, that's actually required to be configured. I don't allow this thing to be null. And I probably want to do the same thing for the game here. So I'm going to do that. I'm going to go back into my application properties. And I'm just going to specify the allow transfer, but I'm going to leave out the game. So right now, what should happen is if I restart my application, Spring Boot will instantiate an instance of my properties object. It will do the binding. It will then perform the validation and says, hey, you're actually missing a field there. So it's going to crash at startup. But rather than just showing you some stack trace and then forcing you to make sense of that, it shows a nice error report where it says, hey, I couldn't actually bind to an instance of this loot properties thing because there was a loot.game property that you were supposed to configure, but it was actually null, and it shouldn't be null. So this also means that it becomes very easy for people to see if the application starts up that they forgot to configure some required property, where it should be, where it's expected, et cetera, et cetera. So that's a really convenient feature. And it's especially nice, I think, for either big projects where you have lots of people working on a large code base and not everyone is intimately familiar with every feature. So now you can discover the actual configuration that's available for your application rather than just having to document it somewhere and then hope that the documentation is actually kept in sync with the actual code, because this stuff is self-documenting. I am currently using this a lot in a project where we're building a set of microservices that have some shared auto-configuration libraries. And all of that auto-configuration has some configuration in there as well to tune it. So by providing these sort of configuration properties instances with your auto-configuration, again, it becomes very easy for people to discover what it is exactly that they can configure and that they are supposed to configure when they're using some of your features. Some other things I'll quickly mention and then we'll move on is that if you're using the Spring Boot actuator functionality, there's also a dedicated endpoint, by default it's called config props, on which you can see all of the instantiated configuration properties in the application context and their actual values, which will include your own custom configuration properties, obviously, if you specify those. And they announced in the upcoming Spring Boot 2.2 that if you have an add configuration properties class, it will actually be automatically component scanned, so you don't actually even need the add component or the other annotation that I showed you anymore, which makes it even easier to start using this functionality. Now, there was a thing I showed you where actually built in already into the IDE, it suggested a name like loot.allowTransfer, which was bound to a Java property called allowTransfer with camel casing. What I could also do is I could actually specify like something like an environment variable, all uppercase with underscores. That would work in binding as well. Now, I noticed before when someone was asking about people still using Spring Boot 1.5 that some hands went up. If you wanted this functionality called relaxed binding in Spring Boot 1.5 and below, you actually were forced to use a configuration properties class like this. However, for those of you thinking that that's still the case, they actually completely overhauled this binding mechanism in Spring Boot 2. So in Spring Boot 2, as long as you're using what is called kebab casing, lowercase with dashes, you can even use simple add value annotations, and you will get the relaxed binding support. So you're no longer forced, basically, to use a configuration properties object just for that one purpose, just so you know. I have no idea, by the way, why it's called kebab casing, but with that, we're going to move on. Metrics cardinality. This project that I was mentioning is actually my first project that we are heavily using the new metrics support from Spring Boot in. And while working with that, I did some tuning and some other things that I quickly wanted to show you here, including this thing about dimensionality. So if you haven't seen that yet, starting with Spring Boot 2, they have built-in integration with something called Macrometer, which is an abstraction layer for exposing metrics to a variety of time series metrics databases. And a lot of instrumentation out of the box for all sorts of Spring components. So you get metrics about your MVC controllers, RestTemplates, the JVM itself, Tomcat, et cetera, et cetera. And that's super useful for seeing what is happening with your application. There were some demos in the previous presentation here. Basically, what metrics are is it's some statistic gathered in typically over something like 1 minute that exposes a value. That could be a counter, it could be the duration of something, it could be just a number of something like the price that you had for selling a product or something like that. And there will be some associated key value pairs with every piece of data there. And those values are called either dimensions or tags, they're the same thing. So for example, when you're using a REST template with Spring Boot app, you can automatically get some metrics out of that whenever you make an HTTP request that will tell you the duration of that request. How long did it take to handle this? But in addition to that, you will see what URL we're calling, what HTTP method we're using, was it GET or POST, what was the status code of the response, was it successful or not, and a bunch of other stuff. And this gives you a very easy way to get insight into the workings of your application. Now, the idea behind these tags, like the HTTP status, for example, or the HTTP method that you use, is that you can use them for things like filtering in your monitoring tools. So maybe I want to say, only give me the success requests that I made that resulted in the 200 OK or something in the 200 range. And I'm not interested in the 500s. Or maybe I actually want to see both, but I want to see them separately, so I can compare how many success requests I'm making to how many requests are actually failing. So that's very useful functionality, but it's only useful if the actual number of values for one particular tag or one particular dimension is somewhat limited. If it's unbounded, if it grows too much, it will just become too much information. It doesn't actually work if you even do that, because Spring Boot, rightfully so, refuses to keep all of that information in memory and then pass it on to your metrics tool all at the same time. So you need to make sure that you somewhat limit the amount of values that any one tag can actually have. So to show you that, let's look at another example that I created for you, where we have a simple web application with a controller, which is here. And what this controller does is, let's see, just a second. Yeah, so this controller simply has two endpoints. One allows you to perform a search request, and that search request takes a request parameter called query over here. So that means that when we make a request, we can pass in some query string, and then in a regular application, this thing would perform an actual search. What I'm doing instead is every 2 out of 3 times, I'm just saying, OK, we tried, but there were no search results. And every 1 out of 3 requests, I'm just going to throw back a custom status to have some different values there in the metrics. And we have another one where I can post to /loot. With that, I now have this Spring Boot application that implements the command line runner interface. So what it does is it uses a REST template that I have configured to make a bunch of requests to this MVC controller after the application has started up. So I'm just going to make 1,000 requests. Or actually, I'm going to make 2,000 requests, because I'm going to make 1,000 requests to every controller method. For the query one here, I'm just going to append the actual number of the request that we're doing. So it's going to be 0 up and until 999. Let's start this up, and let's then see what happens. So while this starts up, you should know that for this application, I've also, here in the POM, configured an HTTP client. Actually, Spring Boot will automatically pick that up, and it will use my Apache HTTP client rather than just a java.net URI to make the request. And I've configured the actuator support, and that's actually important here, because that will activate support for metrics. So looking at my console, I can see that I made a bunch of requests with different results. What I can do now is I can actually go to a browser here, go to localhost 8080/actuator/metrics. And what I will see then is an overview of all of the different metrics that were exposed by my application. So that's quite a lot. One of them here is a metric which is called HTTP server metrics. Requests, I'm sorry. So what we see here is that we made a total of 2,002 requests, because it's also counting these requests that I'm currently making to my actuator endpoints. I can see how long it took to make those requests. I can see some additional tags or dimensions. So we can see we did both post and get requests, and we made requests to /search, to the metrics. My browser did one to the fav icon and to the loot one. We had different outcomes. We had client errors and successes, because we had 402s, 200s, and 429s. Right, so that's very useful information. In this case, this is actually rather limited. If you would export this to an actual metrics database, you will be able to get much more out of this. But I also have client requests here. And this shows me information from my REST template, the timer of the REST template operation, as it says here. Now, if I were looking at the values here, then you see that there is a bunch of different URLs here because I have different query parameters for everything. There is one for loot, and then there's a bunch of other ones for query. But this is not 1,000. This is close to 100. And then it stops. There are no additional tags here. And the reason for that is that it would simply be too much information. So if I'm going to scroll back here a bit, then somewhere close to the top, we will see an error message here. And this warning actually says, hey, you reached the maximum number of URI tags for the HTTP client request. Are you using URI variables? So that's a good question. I'm not. It was interesting. I was at a talk today from Marcin and Olga about Spring Cloud, and they were actually using a URI template builder to construct URLs with query parameters and then passing them to the REST template. You would get exactly this result. So you're going to probably run into this error. Now, in this case, it would actually be rather straightforward for me to fix this, because what I could do is in my demo class here, I could just say, you know what, I should be using a placeholder here. And now say, just pass the placeholder as a var arg parameter right here. And this will actually fix the problem if you do this in this case. I'm not actually going to demo it because I want to show you some other stuff as well. But this is not always an option, right? You may be making requests to URLs that were simply passed in from somewhere else, and you may not actually have the option of saying, I'm just going to rewrite this and do some URL query parameter. So in that case, what do you do? And that's exactly what I wanted to show you. So here, what I have in my loot package is some configuration for metrics. And it's disabled right now, but I'm going to enable it. And then what you see here is that we have a bean here of type meter filter, which allows you to actually say, I'm going to look at metrics before they are being published, and I can do some post-processing on them. So in this case, what I'm doing is I'm saying, if there is a tag called URI, and that could be from a REST template, it could be from something else. But if it's a URI, I'm going to check if there is a question mark signaling the start of some query parameters. And if there is, I'm just going to cut it off. Otherwise, I'm just going to leave it as is. There is another thing here that I'm quickly just showing you because I think it's a nice feature. There is also a monitoring request tag and meter filter here. We have some instances in our application of operations that are not really called that often by clients. But we are calling our own operations a lot for monitoring tools, just continuously checking if our application is up and if it's healthy. So sometimes those tests, those monitoring tests, will actually drain out the actual traffic, so it becomes hard to see how many real requests people are making. So what I'm doing here is I'm actually looking for a request attribute from the incoming HTTP request that I called X monitoring. And if that is there and it's set to true, I'm going to put a tag in my metric saying, oh, this was a monitoring request. And otherwise, I'm going to set it to false. And with that, it will become very easy again to do filtering in your actual monitoring tooling to see the traffic caused by your own monitoring versus that which is actual client-generated production traffic. With this in place, we can restart the application. Yep, stop and rerun. And what we should be seeing now is if I run the same thing again, and look at the metrics, we see that there is only one URL or one URI for all of the REST template calls that was made because we're stripping those query parameters. So the application has run. We're going to refresh. And now, indeed, we see that there's just two values. There is /search and there is /loot. Right? So this is something to keep in mind. This is just one example for a REST template, but this is something in general that you should think about when you're using metrics. If you're going to add custom tags, you should not just have like an unbounded number of potential values, because that goes against the idea of having these dimensional metrics. And this is a nice way to actually keep that within some bounds. Okay, builders and customizers is another topic that is actually quite common to Spring Boot using. In the typical Spring app, you will use a lot of helper classes. Some of them can be from Spring itself, like a REST template, but also things like Jackson object mappers, and they typically need some configuration. So usually people will just create them directly in the class where they need them, like a field, or maybe you have a bean that you create for that, like here on the slide, where we simply return a new REST template. The problem is, very often Spring frameworks or things building on top, like Spring Cloud, they need to provide some common configuration to these things. So maybe they want to register some interceptors with every REST template that's being created for metrics, as I just showed you. or distributed tracing with sleuth or service discovery so that we can do some additional stuff. There's also support in this for testing, for example, and setting up mock MVC. So how do you actually make sure that all of the instances that are created in your application get this shared configuration? And a common pattern for this in boots is to have builders. And these builders will be created by boots, some auto-configuration. There will be a single instance. But you can customize these things by creating your own beans of some customizer type. Actually, I saw in the presentation on migrating to the latest Spring Cloud stuff today that they're actually going to have just a generic customizer interface, which will just be parameterized for this. But there are a lot of concrete interfaces there as well. And the idea is that these builders will automatically find all of these customizers, and these customizers will either customize the builder or the result of what the builder creates, like a REST template. And then everywhere in your application where you need a REST template or you need an object mapper, you will just use the corresponding builder, you inject it into your code, and you say, give me the corresponding instance, maybe after doing some additional configuration. So, another reason that Boot provides you with these things is that it provides some non-default configuration or default configuration that's different from the defaults provided by the native libraries. So you can have some Boot-specific opinionated defaults. For example, with Jackson, we will just get an object mapper that doesn't that simply ignores unknown fields. With a REST template, you will get an HTTP client configured based on whatever is on your class path, that sort of stuff. And this is all done in, for the REST template in auto-configuration. So I want to show you something here where I want to show the importance of using the builders. So we have another application here. Close all. And stop this. There we go. So we have a very simple Spring Boot application. As you can see, it just starts up. And then what it does is it configures this self-invoking controller, which is a REST controller with a first and a second path mapping. And then in the first, it will use a REST template to make a call to the second. That's all it does. And currently, we have this field REST template where we're just creating the REST template ourselves. Also, and I'm not going to show you because I want to save some time, I have configured a dependency on sleuth. So that means I'm going to get distributed tracing support in this application. And then I'm now going to start up the application. And then when it's started up, I'm going to make a request to /first, which will use the configured REST template to make a call to second and then returns the result. Right? So 8080 /first. It gives me a hello from second, exactly as expected. And now I have some logging here. Now this logging is actually showing some numbers. And this is distributed tracing from sleuth. And the first numbers here, which I want to point out, these are trace IDs. The idea is that when a request comes in, we can create a unique number, and we can propagate that to downstream calls so that we can get the same number in all of our logging, which is really nice if you're doing microservices-based architectures. But you see here that we don't actually get the same numbers. When we get back into the controller and do the call to /second, we actually get a different trace ID. And that is because our REST template has not been configured appropriately. Also, going back to my browser, trying to actually get the metrics, they're not there. There are no metrics currently configured for the REST template, even though I did make a request. And the problem is I was creating this REST template here myself, rather than through a builder. So what I'm going to do is I'm going to get rid of this. I'm going to make sure to inject the actual REST template here. And I'm getting an error already because I haven't configured any REST template bean. So I'm going to do that next and say I need a bean of type REST template. Inject the REST template builder here. And then say return, in my case, just builder.build. I don't need any additional configuration. And now when I restart my application, what will happen is I will get a REST template configured through the builder, and there will be some additional built-in configuration from the various frameworks I have on my class path applied to the REST template for me. So that means when I go back here and I make another request to /first, and it says hello from second, and this time you can see I'm actually getting 3 of the same trace ID here rather than just a single one. That's different for the second call. And refreshing this, I now get my metrics back again as well, right? So that's one of the reasons that you should be using these builders. Now, I'm not going to demo it, but it turns out that actually if I would have created a bean, but I wouldn't have used a builder, I would just have said return new REST template, I would actually still get the distributed tracing support. But I wouldn't get the metric support, so it would sort of work. You may wonder why that is, and actually it's because Sleuth does a slightly different trick. They use a beam post-processor where they will just take any REST template that has been configured in the application, and then they say, oh yeah, I'm going to just inject my custom interceptor as the first one to be used in the REST template, without necessarily doing that through a builder. But that's not true for all of the support in Spring Boot. So for example, like I showed the metric support, it doesn't actually work like that. So you wouldn't still get any metrics for this. So the advice in general is just always use a builder. You'll be good. And you can also do your own custom configuration. So here, for example, just to get an idea of what that's like, I have configured a customizer for Jackson, which is a sample out of our actual application where we say, if we want to serialize offset date times, which is a standard Java 8 type, we want to have some different representation of that. And this will actually ensure that every object mapper in our application that we create through Spring will have that configuration applied. There is actually another example, but I'm going to skip it now, but you will find it in my repo, where I'm also showing how you could register a custom interceptor to do request and response logging for every request that you make with your REST templates. So if you're interested in that, make sure to have a look. We're just going to skip it for now, because there's some other stuff I want to talk about. Another common thing I find in building Spring applications is that you need some customizations for the local development setup. You want to have some different configuration properties. You want to have some Spring beans in a different setup because you don't want to have security enabled, or you need some different URLs configured, or you don't integrate with something like service discovery and that sort of thing, or shared configuration services. So how do you set that up? And a common solution for this is where people will just use a Spring profile. So it says I'm going to define a local Spring profile, and then I get automatic support from boot for some customized configuration properties, like application-local.properties. And next to that, I can have my custom configuration beans in place. So I can have Spring configuration that's just tailored to my local development environment. So that's something that you may already be using today. The thing is, if you want to enable a Spring profile, the typical way to do that is to use spring.profiles.active property. Now, I'm working on a microservices-based architecture with like 30 services or something like that. I really don't want to have to specify that property in every run configuration in my IDE, for example, for all 30 services. So how do you deal with that? Now, one way for that could be to say, I'm going to make all of my developers configure an environment variable, which is called Spring Profiles Active. And that will actually automatically bind to the spring.profiles.active because of relaxed binding support. And then you will have that local profile whenever you run locally and not whenever you run somewhere else. So that's actually a nice solution. However, there is a problem there. If you want to configure some additional profiles, then you will be likely to just override the Spring Profiles Active that was configured to the environment. Because these things do not add to the same property, they just override. So for this, something that most people I've noticed are not familiar with is that there is a spring.profiles.include property. So rather than saying Spring Profiles Active, you can configure a Spring Profiles Include, which will actually add to any of the profiles that you have activated through the profiles.active thing. So what we do in our project, and I can show you, is that I have some environment variable here, which is called Spring Profiles Include, which I've set to local, which means that whenever I start up a Spring Boot app on my local machine, I will have a local profile active, in addition to anything else that may or may not have been configured. The other thing here, by the way, ensures that I always get nice colored output from Spring Boot in my console, because even though I'm running on Windows, I think I still deserve to have some color as a developer when I'm running on the command line. And this is not enabled by default. So what can you configure for local development? Well, it's typically stuff like unique ports per service, right? We're running on Docker, so in production everything is port 8080 and it binds to some random port at runtime. But we're not running everything in Docker when we're running locally. We just start up boot apps, so they need a unique server port number. There's disabling functionality you don't actually want to have, or enabling things you just want to have when you're running locally. So this is just some examples of that. One particular example I wanted to mention here is logging. Even if you have a dedicated logback file, you can still do some customization through Spring Boot properties. So you could say, for example, well, with Sleuth, as I showed you, you get all of this output where there's a trace ID and there's a span ID, and they say if the span will be exported or not. It's just not useful, typically, locally. I'm just interested in the trace ID. And by saying, oh, I'm just going to override the logging pattern level here with this custom setting, I can make sure that I only see the trace ID locally and not half of my screen is actually used by the other's configuration there. Or I can do custom log level customization for local development. So that's some of the things that are useful there. Let's see, we still have 5 minutes. So next thing I want to show you is something that I encountered when migrating existing applications onto Spring Boot. So what I've done a lot myself as well is that when you're running a Spring application without boot and you need to read some configuration resources, things like key stores, for example, and other files, from somewhere, you're just going to configure an external Classpath directory. The nice thing about doing it like that is that people will be able to update these files and change them without creating a new deployment because they're just external to the app. But your app still doesn't need to know where these files are located because you can configure the class path outside of the application itself. So I used to use that mechanism actually quite a lot. But then Spring Boot came along with its default packaging mechanism of saying we're going to put everything in a fat jar. This is a fat jar. And that's your class path, right? You're going to get your bootinf lib and your bootinf classes from inside the jar, and that's it. And if you then want to migrate an application to that, but you're customized already to reading a lot of stuff from external Classpath directories, that's going to be a problem. Now, the good news is that there is a built-in solution for this, but again, it's my experience that a lot of people don't know about this, because a boot app is started up using a launcher, but you can tell it to use a different launcher than the default one. And you do this through configuring a so-called layout in your plugin. So for Maven, it looks like this. Actually, if you configure this, the actual layout, the way that your fat jar is created, is not really all that different, but it will use a different main class as your launcher. And, oops, sorry, that was one too quick. And that launcher is called a properties launcher if you use the zip layout. Now, with the properties launcher, what you can do is you can configure one or more external directories to be added to your class path at startup. The way that this works is it looks for a file called loader.properties in the root of your class path, so you could package it up with your application, or you configure this through the manifest, or even through environment variables if you want to make this more dynamic. And then you can configure in either of those locations a property called loader.path with one or more comma-separated directories. And these will be added automatically to your class path when your application starts up. So I have a little demo for that as well. Let's see. Here. So in this case, what I have is I have a very simple app. All it does at startup is it reads a file called truststore.jks from the class path, the root of the class path, and then prints out the actual configured aliases of the certificates in that key store or trust store. And I have a loader.properties file here, which is configured to read a directory called ext for some extensions. And I actually have an ext directory here with a truststore.js and a logback.xml. So now what I'm going to do is I'm actually going to drop down on the command line. I'm going to do a build of this application. And the reason I'm going on to the command line here is I actually want to have this jar. I don't want to run this thing from IDE. I want to simulate this setup where I'm actually running a fat jar in production. But next to that jar, as you can see here, I have my X directory, right? And that's where I'm going to read the logback.xml from, and I'm going to read this actual trust store file from my command line runner. So what I can do now is I can say java-jar target external snapshot.jar. So it will start up, and you can notice two things here. First of all, I have some actual logging here. And second of all, there is the output here that says I've loaded the trust store and I found 3 different certificates in this thing. I can show you that this works because if I would move to the target directory now and I would try to start the same thing from here, it won't work because that X directory was actually relative to my working directory. So right now it's actually failing with a file not found because it says I don't have this file. I cannot read this trust store at startup. So one of the results of doing this is that someone could now actually change your log configuration outside of your application, but still the logback.xml is just read from the class path, as is common for most applications, right? I'm using another feature here where we're actually importing some default boot configuration in the logback, so I don't have to set up everything myself. So that's pretty much that. So in conclusion, because time is up, I think boot is awesome, but that doesn't mean that you should just be satisfied with whatever it brings out of the box, right? It's a framework that very easily allows you to configure stuff or to actually use the same mechanisms that boot uses internally for your own application. So you should look into those customization and configuration options there. It really pays off to read configuration, or what's actually much better is to have someone like me doing that for you, diving into this, figuring it all out, and then explaining it in a 50-minute talk on a conference. So thank you very much for attending. If you want to look at this code yourself and play around with it, on my GitHub, I've pushed this. It's under a bootloot project. I've also uploaded the slides already to SlideShare. And once the video is up, I will actually add the YouTube video to that slide deck so you can follow along. Obligatory, we're hiring slides. We have electrical cars and boats, so it's super cool. Thanks everyone for attending. Time is up, but if you have any questions, I will be around here. So please come up to me and we can talk some more. Thank you very much. Wonderful.